Ready. Here we go. Where do we go? I forget what we're doing.
Oh, yeah,
right here. So what we were talking about right before lunch is occasionally, when you've got like more than 2 sections, when you've got like 3 sections going on, occasionally, not always, you can have points that pass through the horizontal asymptote. They will never ever pass through the vertical asymptote, but they could pass through the horizontal asymptote, and it would look like a point of inflection, which I've told you about before, that kind of looks like the cubic. Point of inflection goes from the graph being concave downward to being concave upward. So that's what the graph's going to look like in between. It's still using the vertical asymptotes, but it passes through the horizontal asymptote. It just has a concave, it has a point of inflection. And then we pick some more points for the right side of x equals 2. And because of time, I will just tell you what I picked. Plug it in. I picked 5. I plugged it in. I got 4/7. So we graph 5 4/7. And we are using our asymptotes. If you're not sure if you use the asymptotes, plug in more points. You will always, always, always use the up and down asymptotes vertical. It's just the horizontal sometimes they can plug in. Not always. All right. Next. What's our first step going to be? Factor. Go factor. My next step is I'm figuring out what makes the denominator 0. And some of you have already done the step after that, right? What did you do? Cancel some stuff. Yeah, that's going to be my next step. So if I can cancel something out, I am going to have a whole. The whole is an ordered pair that the graph is just going to jump over. So on this line, I'm going to be writing an ordered, supposed to be an arrow, an ordered pair. So when I cross off x equals, or x plus 2, that means x is equaling -2 at that whole. X is equaling -2. So my whole is going to start with -2, comma, something else. I have to find out what y equals when x is -2. Do not plug that into the equation you just crossed out. Like, don't plug it into the original, because if you do, that's going to equal 0, and you're going to have the denominator that equals 0, and that's not going to work. So you have to plug it into the simplified equation, x minus 3 over x plus 1. So we're going to plug in -2 into that one. We'll have -2 minus 3 over -2 plus 1. And I get the whole is -2 pi. I'm going to go graph that. -2, 5, it's a whole. So draw it as an open dot. Now I'm going to go back and do the domain. So the domain is everything that x can be. And you say, what can x not be? -2 or -1. So I'm going to skip over those numbers. -2 more negative, so I'll do -infinity to -2 union, -2 to -1 union, -1 to infinity. Vertical asymptotes. That's the denominator. What x can't be, it's going to be our vertical asymptotes. X equals what? Hold on, not -2. What happens at -2? That's a whole. So the only asymptote is at x equals -1. At x equals -2, it's a whole. So they kind of do the same thing where there are places that the graph is not, graphed there. But they look like different forms of the graph. One's a whole, one's an asymptote. All right. Next, horizontal asymptotes. And actually, starting from here down, you're really just using the simplified version. So we're using x minus 3 over x plus 1. So the x plus 1, that gives us that x equals negative 1. So horizontal asymptotes, what do we have? Y equals 1. We're putting 1x, 1 over 1. Slant asymptote. None. X-intercepts, so you're going to use the simplified version, that x minus 3 equals 0, the one that's over x plus 1, but you don't have to do the x plus 1 part. So x equals 3, our x-intercepts, there's just 1 at 3. And then the y-intercept, we will plug in 0 for x, so we'll have 0 minus 3 over 0 plus 1, so negative 3.
Why is there only one?
Because there's only one x on top. There was, remember the number of intercepts would be like the degree. It was 2, but I canceled out one of them.
Why is it just the top and not the bottom?
Because you set the equation equal to 0.
Oh, okay.
And then we cross multiply, the bottom disappears. So it's just the top. All right, so I had negative 3 for the y, I had positive 3 for the x. So I can kind of see, I found more points. I can kind of see where this is graphing using my intercepts. I found, in my table, I found the point 1, negative 1. We just did that really fast. I didn't show you any work, but I did it just trying to hurry you on. Okay. You guys know how to plug in numbers, right? Do I need to go over that part of it? Okay. I also put some other points in. Let's see what else I put in. I put in 1, I got negative 1. I put in negative 3, I got 3. I put in negative 5, I got 2. So graph those, negative 3, 3, negative 2. So that's what the graph looks like around the hole. It looks like it would go straight through it, but it doesn't hit that spot. I'm going to show you on Desmos what that looks like as well. If you use your graphing calculator, or if you use Desmos to check just to make sure you're doing it right. Wait, which one is it? This one? Yeah. At negative 2, 5, do you see a hole? You're not going to see it because points have no length or size. You won't be able to see it. You'll just keep zooming in forever and ever. And what's going to happen is you're just seeing closer and closer and closer to that hole. You're never going to see the hole. On Desmos, if I actually click, it'll show me the ordered pair. And when I go up to negative 2, then it looks like a hole. But you actually literally have to click on it to see it. On your graphing calculator, you can't do that. But on your graphing calculator under the table, you would look and it would have negative 2 for the x and it would say error for the 5 spot for the y. It would say error. So that's all you can do. So you really have to understand how to do it because you can't see it using technology. All right, last question. What should you do first? After. Once you factor it, say what x cannot equal. So our domain, oh, I'm sorry, are there any holes? No, we didn't cancel anything, no holes. Our domain is going to go from negative infinity to negative 1, union negative 1 to infinity. Vertical asymptotes. -1. Horizontal asymptotes. So we have to look at the degree. The degree on top is 2, the degree on the bottom is 1. So they are not the same. So if the degree on top is bigger, no horizontal asymptotes. Before we go on, we didn't have any examples like this in our notes. What if the degree on the bottom is bigger? It's y equals 0. Get that from your notes. We didn't do any examples. That was really easy. So there are no horizontal asymptotes. The next thing we need to check is if we have any slant asymptotes. If there's no horizontal, there might be a slant. So is the degree on top 1 more than the degree on the bottom? Yeah. So we do have a slant. We have to find it. We do that by division. So you can, since it's x plus 1, you could use synthetic. I'm using long. It is not much work either way. And then I told you this earlier, but it's before lunch, so you don't even use wording here. We use the top. It's going to be y equals x minus 2. That is our slant asymptote. So now we graph y equals x minus 2. That's a line. How do we graph that? Where do we begin?
It's a transformation down to.
From, okay, so what's the, is there any stretch or shrink? Okay, so it's just straight through the middle, down 2. We have a y-intercept at -2 with a slope of 1, up 1 over 1, up 1 over 1. So those are the asymptotes. I find our x-intercepts by putting the numerator equal to 0. So we have 0 equals x minus 3 and x plus 2. So we'll have one x-intercept at 3, one x-intercept at -2, but when I ask for intercepts, I want an ordered pair. What would it be called if you made a big list of them? What would I be asking for? You just listed them. Zeros, thank you. I think some of us did not truly understand that on that quiz that we took last week. If it's intercepts, you're writing ordered pairs. If it's zeros, you just list them. Y-intercept, we plug in 0 for all the x's. I'm going to plug it into the original question. Oh, gosh. I'll plug it into the original question, which is like 0 squared minus 0 minus 6 or 0 plus 1, so -6. What French grammar? I've got the different colors. Let's see. There we go. All right. Can you look at that right now and know what the graph looks like? If the answer is yes, go ahead and graph it. If the answer is no, we find more points. I'm not going to take the time to plug in points one at a time and solve it. I'm just going to give you some more points. Actually, I only found one, but you could find more if you need them. I plugged in -3, and I got -3. You guys can practice that on your own when you're working on your assignment. Ooh, I did plug in something else in the last class, but I do not remember. Actually, it's over here somewhere. What was over here? Okay. This graph will use the asymptotes. for your assignment, I have a big packet. It is odds due next class. And I only want you to do, well, not really, but I want you to do odds first. Because if there's something you're not getting, I want you to not be able to do, like, the whole assignment. Okay? So if there's something you're not getting, come with questions. And then we'll do evens on Friday. If you're going to come and you're like, you know what? I want to get ahead a little bit. You can work on more than just odds. I'm just letting you know now, I'm trying to not give you work over the weekend. So if you can work ahead, you're going to accomplish that. You won't have anything to do on Sunday but flip you Friday.
So Friday, after school, is when we go
Friday, you will get to work on it in class.
Oh, in class.
But depending on how fast you are, I don't know if you can get 6 questions done in class or not. Now, if you've done the first 6, you'll definitely have a better idea if you can do the second 6. If it's taking you a while, work ahead. I mean, if you get it, but it's taking you a long time, work ahead. You know? I don't want you to have homework this weekend.